Namaste, and welcome to you all in this beautiful session of Beauty of Mathematics. And we have with us presenter Megha Relan. Am I audible?
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Good evening.
Okay. So Megha Relan is the presenter. She is the head of the Department of Mathematics in Mathematics-Megha, Delhi, and has been teaching since 12 years. Before that, she has also served in other school. A very young, energetic, enthusiastic, and very popular teacher, because generally mathematics is known as a very dry subject. But she used to teach in such a way that children are very fond of her. So, welcome, Megha. And with us,
Thank
we
you so much,
have
sir.
Dr. B. Kaur, the Assistant Commissioner, retired from Kendriya Vidyalaya Sangathan. She will preside over the session. She is also a lady of mathematics, and 3 decades she has spent in teaching mathematics, making mathematics easy, conducting mathematics workshop, mathematics training. And there was a time when the Kendriya Vidyalaya Sangathan used to conduct any workshop, any training. So Madam Pinder Kaur was used to ask to conduct the workshop. She has a lot of experience in scouting and guiding also. She has worked as a Deputy Commissioner of Scouts and Guides, and also involved in many social issues, and very lovely, very jovial, very energetic, and very enthusiastic. Still, she is busy in many programs related with the social cause. So, welcome, ma'am. Welcome you in this session. I'm very happy that you have kindly graced the question. So, welcome to you. And Megha, the stage is all set for you. Please.
Thank you so
The
much,
beauty of
sir.
mathematics.
First of all, thank you so much, sir, for providing me this opportunity. I'm really grateful for this. Uh, I'll just share the screen. Please let me know if it is visible.
Yes, yes. I can see you and hear you also. Good evening.
Good evening, ma'am. Good evening, everyone. As you can see on the screen, our today's topic is the beauty of maths. And I, Megha Relan, is here today to talk about how maths is visible everywhere. And it is the discipline that allows us to examine so much of our world. Let's start with a beautiful quote. I would like everyone to please switch off the mic. So, Jay sir. Jay sir, please can you switch off the mic?
Actually, maths meeting. Just a second. Yes.
Yes, I would like to start off with a beautiful quote. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. A beautiful quote by William Paul Thurston. While numbers are not an important part of mathematics, it's a common misconception that maths is only about numbers. At its core, mathematics is the science of patterns, logic, and reasoning. Maths is not just a tool for solving problems, but a language that describes the world around us. It has language it has both logical precision and artistic elegance. From simple numbers to complex theorems, Maths unveil a deep beauty in patterns, structures, and relationships. It is the study that discovers and organizes methods, theories, and theorems that are developed and proved for the need of empirical sciences and mathematics itself. It is the science that deals with the logic of shape, quantity, and arrangement. Basically, math is all around us in everything we do. One of the most important branch of mathematics is geometry. It is the branch that studies shapes, size, angles, and dimensions of the things of the world. And nature is a great example of it. There is symmetry everywhere in nature, if we'll see. Look at these beautiful flowers on the screen. Symmetry not only make them look beautiful, but it is also very important for the pollination and reproduction of flowers. Radially symmetric flowers are accessible to a variety of pollinators from all the directions, which help them reproduce in a non-competitive environment as well. Butterflies have bilateral symmetry, which means that their bodies can be divided into two identical halves by a single line of symmetry down the middle, which means patterns on both the sides, on both the wings of the butterflies are identically same. This makes them a fascinating example to explore symmetry. Starfish have radial symmetry, which means that their body is made up of identical segments that radiate out from a center point. There is one more interesting fact about starfish. The perfect starfish has a five-fold rotational symmetry about the axis through the center by 72 degree, 144 degree, 216 degree, 288 degrees, and 360 degrees. So that's how your maths is also there in animals. Now look at this beautiful peacock. The delightful peacock fans his feathers to impress the peahens. His feathers span long and symmetrical, proving that he is the most beautiful to win over his suitor. Another beautiful example of maths in real life is honeycomb. Honeycomb is a mass of six-sided wax cells built by honeybees in their nest to contain young bees and stores of honey. The maths of honeycomb is based on honeycomb conjecture, which states that a regular hexagonal grid is the most efficient way to divide a surface into equal areas while minimizing the total perimeter, which means that honeycomb pattern is the most spatially efficient design, leaving the least amount of wasted space between the objects. So see, bees are actually using maths in making their honeycomb and just keeping their honey safe. How maths is useful over there as well. And these days we can see honeycomb conjecture. It is even used in food packaging, furniture packaging, lamp and lighting packaging because it is very easy and it is used to protect the fragile items during transit. So honeycomb is one of the biggest example over here. Patterns and symmetry is not only restricted to nature and animals, but it is also evident in the day-to-day things that we are using, like onion, kiwis. If we are cutting them, look at the patterns that is there on the screen. It is just making them look more beautiful. A very, very important concept that we'll now be discussing is the Fibonacci sequence. Many seed heads, pine cones, fruits, and vegetables display spiral patterns that, when counted, express Fibonacci numbers. Look at the spiral seeds at the center of the sunflower, the fourth image, and you'll observe patterns curving left and right. If you count these spirals, your total will be Fibonacci numbers. Fibonacci sequence is a sequence in which each number is the sum of the two numbers that precede it. Numbers that are part of Fibonacci sequence are called Fibonacci numbers. Fibonacci sequence also appears in rabbits' reproduction system. Fibonacci originally came up with the sequence when working on a puzzle related to rabbit breeding. The scenario was described as follows. You start with one pair of newly born rabbit. It takes 1 month for rabbits to reach maturity. Each month, each pair of mature rabbits will breed. And after 1 month of gestation period, a new pair of rabbits is born. Rabbits generally don't die. They don't die naturally. How does the number of rabbit pairs will increase with the time? And the answer comes up as a Fibonacci sequence. At the start, you will have one pair of rabbits in the field. But after 1 month, the pair has matured and they start to breed. But still, you will have just one pair in the field because they have just started to breed. After 2 months, the first new pair is born and the original pair breed again. But in the field, I can see the total of 2 pairs of rabbits. Now, after 3 months, a new pair is born, and both the original pair and the pair born in the previous month breed. And now you will have 3 pairs in the field. After 4 months, 2 new pairs are born, and 3 pairs breed. That makes 5 pairs in the field. After 5 months, 3 pairs are born, and 5 pairs breed. And that makes 8 pairs. Eventually, the number of pairs in the rabbits in the field are 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. This is nothing but a Fibonacci sequence. And normally we say if we are following this procedure, we are following this sequence, after 12 months, there will be 144 pair of rabbits in the field. So that's nothing but a Fibonacci sequence and the use of Fibonacci sequence that is there in the real life. All right, there is one question for you all. Can you all guess what is the similarity between all these images? Can anyone tell me something? Can you see any similarity between all these images? This is pyramid, the pyramid of Giza, one of the 7 wonders of the world. Then we have Twitter logo, we have Pepsi logo, we have famous Mona Lisa painting of Leonardo da Vinci. Anyone who can see any kind of similarity between them, though with a naked eye and as a layman, it might be difficult, but anyone who can tell me? Let's
Good
see.
evening, ma'am.
Good evening.
Ma'am. This is golden ratio. They are in perfect symmetry with each other,
Exactly.
and
We have so many mathematicians over here that we know about this. This is nothing but a famous golden ratio that is there. You were saying something, ma'am?
exactly. And we get this ratio by dividing the numbers of the Fibonacci sequence.
Exactly. Golden ratio is what I'm going to discuss now. A very fascinating example of mathematics. See, these all pictures, these all things are designed using golden ratio. The golden ratio is a mathematical ratio. It is commonly found in nature and one second. It is commonly found in nature, and when used in design, it fosters organic and natural looking compositions that are aesthetically pleasing to the eye. The golden ratio, denoted by phi, also known as golden number or divine number, is the ratio between two numbers that equals 1.618, as what ma'am said. Golden ratio is special because it perfectly balances addition and multiplication. The Great Pyramid of Giza, that is one of the 7 wonders of the world, is believed to have been constructed using golden ratio. The ratio of the slant height of the pyramid to the half of the length of its base is 1.61950, which is very close to the golden ratio 1.618033. These are all approximate figures. The golden ratio is also known as sacred ratio and was used by ancient Egyptians and Greeks. It is a mathematical term that can be found in many aspects of nature, architecture, sculpture, and even in human body, which we'll be discussing soon. The next image was our Twitter logo. The Twitter logo uses golden ratio to create harmonious proportion. It is made up of 15 circles that are layered on top of each other. The proportion between larger and the smaller circles are close to golden ratio. The last picture is of famous Mona Lisa painting by Leonardo da Vinci. The horizontal distance from the left side of the painting to the Lisa's left eye and then to the right edge of the painting is 1 is to 1.618. That is our golden ratio. The width of Lisa's forehead compared to the length from the top of her head to her chin is perfectly golden rectangle. A golden rectangle can be fitted to several other features of the painting as well. And that is why it is also considered as one of the most beautiful painting. Golden ratio is not only restricted up to architectures or sculptures, but it is also applied to the facial aesthetics. A visually balanced face is approximately 1.618 times longer than it is wide. The distance from the top of the nose to the center of the lips should be around 1.618 times the distance from the center of the lips to the chin. The hairline to the upper eyelid distance is classically 1.618 times the length of the top of the upper eyebrow to the lower eyelid. The model ratio of volume in the lips is 1 is to 1.6, the lower lip having slightly more volume than the upper lip. And all this is nothing but our golden ratio. You can see how it is applied to the facial aesthetics and how we say a beautifully balanced face looks like this. But when they follow the golden ratio. Yes, maths is not only restricted up to nature and sculptures, monuments, but it is also important in today's technology. Maths is essential to technology as it underpins many of its foundational principles and algorithms. Mathematical principles are used to ensure that designs are safe, functional, and efficient. For example, engineers use mathematical principles to design aircraft, bridges, and computer chips. Mathematics is used in encryption and cryptographic algorithms that secure digital information, which is very important in these days. Cybersecurity experts use mathematical concepts to design digital signatures and authentication. Data analysis. Mathematics is used in data analysis techniques across many industries. Mathematics is also the foundation of artificial intelligence and machine learning. It provides tools and framework for developing AI models and algorithms. In engineering, mathematical modeling is a key component of design and analysis. Engineering uses mathematical models to simulate and optimize the behavior of system and process, forecast how structure would behave under various loads, and develop electronic devices. Yes, maths is very much related to art and music as well. Math and art, including music, are deeply connected in many ways. Both art and music are built in patterns, and the ability to understand patterns is central to both the disciplines. Fractions. Composers use fractions to divide a musical whole note into parts such as halves, quarters, eighths, and sixteenths. Scales and chords. Scales can be represented mathematically using frequency ratios, and chords can be represented using intervals and frequency ratios. Rhythm and time. Music is made up of beat and rhythms, which can be represented mathematically using frequency and fraction and ratios. Brain activity. Yes, the research shows that same areas of the brain are used for both math and science, and that practicing music can help reinforce those areas. And sometimes we have even heard in our classes that students say that, and even I was one of the example of it. I used to enjoy maths. I used to study maths while listening to music, and maybe this is the scientific reason, but yes, it helps to understand maths in a better way. And that is why we also say that musicians must have an understanding of fractions as well, so that they know how long to hold a note in a musical piece. Many mathematicians have created art like MC Escher, whose work explore impossible shapes and mathematical concept. MC Escher was known for his tessellation, which are a way of covering a surface with repeated shapes that fit together perfectly. Escher used complex mathematics, especially geometry, in his work. You can see beautiful examples of the Escher's work, some few of what I can bring here for you all. He has used maths in such a way and how maths is used to make the beautiful tessellations. And these are all noteworthy tessellations made by Escher. Now I would like to conclude the PPT by saying that maths is more than just numbers. It is a beautiful language of patterns, logic, and discovery. It is a universal language that reveals the inherent beauty of the world. Mathematics reveal the elegance of the universe from the tiniest atoms to the vasting of space, to the vastness of space. It encourages creativity, problem solving, and critical thinking skills. Study of maths is not only about numbers, but it's about discovering the beauty in logic, form, and harmony. I would like to wind up this PPT by saying, by some beautiful quotes. God used beautiful mathematics in creating the world, truly, as what we have seen right now. The mathematician does not study pure mathematics because it is useful. He studies it because he delights in it, and he delights in it because it is beautiful. Thank you so much. Sir, do I have some time? I have few videos to be shared. Sir, you are on mute. We cannot hear you.
You have time. Please go through.
Sir, I want to share one or two videos with everyone
Please, please.
about the beauty of numbers. One second.
You have plenty of time.
Is this video audible?
I think voice is not coming.
One second, sir. Just arrange it. I hope it's audible now.
No, no.
No, ma'am. Voice is not coming.
One second.
Ma'am, you need to share this screen separately. You need to reshare the screen with this particular screen.
Dinesh sir, can you help me with this? Yaksha sir, I've shared this video already with you. I have already mailed this video. Can you share this if possible? I'll just try once again. Is it now audible?
Ma'am, actually, you need to share this video separately in a different screen.
So, Akshay sir, can you share this on my behalf?
Just a second, ma'am. I'm just checking.
Yeah, I have mailed you this this one. 3 videos I have mailed.
Just a second, ma'am. Which one you need to play right now?
Sir, one second. I'll just let you know. So, the beauty of mathematics.
Is this visible?
Yes, sir.
Now,
It is visible but not audible. But I
not
guess we
audible.
can even see this. The audio is not, it won't make much of a difference.
Yeah, it's only the music.
Yeah, it's only the music.
Okay, okay.
The beauty of mathematics, the interesting way to look at the beauty of mathematics. That is there in this video. Few examples. 1 multiplied by 8 plus 1 is 9. 12 multiplied by 8 plus 2 is 98. 123 multiplied by 8. Sir, can you just pause for a second?
Sure, sure.
थोड़ा पीछे. Yeah, बस.
This one?
123 into 8 plus 3 is 987. You can see the sequence that it is following, the pattern that it is following. 1, 2, 3, 4 into 8 plus 4 is nothing but 9876. 1, 2, 3, 4, 5 multiplied by 8 plus 5. I am just adding up the numbers. It makes it 98765. That's the beauty of numbers that we normally talk about. 1, 2, 3, 4, 5, 6 into 8 plus 6 is nothing but 987654. 1, 2, 3, 4, 5, 6, 7 into 8 plus 7 is equal to 9876543. Here I am adding the number. Here we are going in the reverse order. When I'm adding one more number, 1, 2, 3, 4, 5, 6, 7, 8 multiplied by 8 plus 8 gives me 9876543. And 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplied by 8 plus 9 is 987654321. A beautiful sequence. So you can play. Similarly, we have one more here. 1 multiplied by 9 plus 2 is 11. So 12 multiplied by 9 plus 3 is 111. 123 multiplied by 9 plus 4 is 1111. 1, 2, 3, 4 multiplied by 9 plus 5 is 11111. We are just adding up 1 over here when we are adding up the numbers here. That's a beautiful sequence of numbers. One more example. 9 into 9 plus 7 is 88. 98 into 9 plus 6 is 888. 987 into 9 plus 5 is 8888. 9876 into 9 plus 4 is 88888. Yes, truly this is brilliant. So you can play. One more example of symmetry over here. Symmetry in numbers that what we are seeing on the screen right now. From strictly mathematical viewpoint, what equals 100%? What does it mean to give 100%? How does achieving 100%? What equal 100% in life? That we normally use these statements. Here's a little mathematical formula that might help answer all these questions. We have just given numbers to the alphabets A, B, C, D, E, F, G. We have 26 alphabets. We have given number. A is given as 1, B 2, 3, C 3, D 4, E 5, and we'll be using these numbers. Hard work. If we look at those numbers, H is represented by 8, A by 1, R by 18, D by 4, W by 23, O by 15, R by 18, and K by 11, which makes a total of 98%. And when I talk about knowledge, K is represented by 11, N by 14, O by 15, W by 23, L by 12, E by 5, D by 4, G by 7, and E by 5, which makes a total of 96%. That means hard work is 98% and knowledge is 96%. But attitude, that means A is 1, T is 20, I is 9, T is again 20, U is 21, D is 4, E is 5. Attitude is 100%. Hard work is 98%, knowledge is 96%, but attitude has to be 100%. So we can conclude that while hard work and knowledge will get you close, the attitude is what will get you there. Even if I do not have knowledge of a particular thing, but I have that thing that I want to study this, I want to excel in this, I have that attitude, it's there. I'll surely achieve it. And that's what maths also teaches us. Akshay sir, please, next one as well. If anyone want to say anything, please.
Ma'am, which one you need next?
So you can play anyone.
Okay, okay.
Interesting facts about number 7.
All right.
We'll just see a few interesting facts about 7 number. Number 7, a very auspicious number that is used again and again.
Just a second.
Akshay sir, should I reshare the video with you?
Ma'am, actually, this video is not opening. Yes. You
I'll just
might share.
reshare, sir.
Sure, sure,
Or
sure.
I'll share it. It's okay. I'll share the screen. The music. It's only music that is there in the background.
Okay, okay, okay.
I'll share it. Some interesting facts about number 7. This is an example. Normally, children used to say this. This is a quote. Why 10 is afraid of 7? It's 7, 8, 9. That is an example what normally students say is a fun fact. Let's start with the facts now. It's a very special number and you can see its application at so many places. They don't even expect. First fact. Whenever you are rolling two dice, the most probably that they will add up to 7. Probability of getting the sum as 7 is highest. In music, there are 7 basic musical notes. We normally say sa, re, ga, ma, pa, dha, ni, sa. 7 musical notes are there. Third fact. Total number of logic gates are also 7. We have 7 wonders of the world. Total number of continents is there are 7. We have 7 continents. Asia, North America, South America, Africa, Europe, Australia, Antarctica. 7 days in a week. Normally say they're working 24 by 7, 7 days in a week. Number of colors in a spectrum or rainbow, they are also 7. 7 numbers, 7 number of colors. Yeah. And one last video that I would like to share. Some amazing facts about maths. Is the screen visible?
Yes.
Yes,
Yes,
ma'am.
yes, yes. The screen is visible.
Okay, one second. See, the first fact, every odd number has E in it. I am sure because even when I was searching about this, I was not sure. I never knew that this is also there, but yes, this is a fact. Every odd number has E in it, and I even counted it. 1, 3, 5, 7, 9, 11, 13, 17. Every odd number has E. Four is the only number that has same number of letters as the number itself. 4 numbers and 4 letters are there. And the number is also 4. From 0 to 1000, very interesting one. The only number which has letter A in it is 1000. And actually, I saw this, I again recalled all the numbers, and yes, 1000 is the only one which has A in it. 40 is the only number which has letters arranged in alphabetical order. Zero is the only number which cannot be represented by Roman numerals. Do you know the meaning of word jiffy? That's the question. Jiffy is a unit of time and it means 1/100th of a second. I was not aware of. One is the only number that is spelled with the letters arranged in descending order. Yeah, basically it is nothing but converse of 4. Because 4 is the only one in the ascending order. This is in the descending order. Two is the only number that is prime. That is even and prime. In a room of 23 people, there's a 50% chance that two people have same birthdays. Six weeks is equal to 10 factorial seconds. No one can even think about it. Square root of 2 is called Pythagoras constant. Bacchus is considered the origin of calculator. Even when calculator was not there, we used to use a Bacchus for calculation. Have you ever heard about a palindrome number? It's a number that reads the same backwards and forward. Like 12421. And the backward is also 12421. That's a palindrome number. Fibonacci is what we just discussed. The facts that we just discussed. From 0 to 1000, the only number with letter which has letter A is 4. 40 is the only one number which has same letters that are there. 6 weeks is 10 factorial seconds. Square root of 2 is called the Pythagoras constant. Backus is considered the origin of calculator. Palindrome number is the number that reads the same backward and forward. Fibonacci sequence, we even discussed that in nature now. Plus and minus symbols were used as early as 1489 AD. So that's it from my side. If anyone else want to say something, anyone wants to add something. I hope I would like to thank everyone over here who have joined the meeting. I hope I have not bored you here and you have got something was there which we all can learn. Learning is a never ending process and we have learned something new again over here. Many of things you were aware of, but yes, definitely when we go and research about things, we get to know certain facts, and I have just displayed those few facts with you all.
Hello. Hello.
Yes, ma'am.
Are you able to see me?
Yes, ma'am.
Just a minute. I have never thought that the 7 can 8, 9, and the 10 is so confused. He is frightened. And the beauty of the mathematics. Thank you very much. It was so wonderful. I am in travel. Otherwise, I have given more comments. I have thoroughly enjoyed, although I was in a dilemma whether I can join it or not. So thank you very much. And over to you, Dr. B. Kaur. One thing I'd like to know that both of them are, I'll say the beautiful teachers. Generally, mathematics teachers are gents. So our children are more frightened from them. So it is also one point, very positive point. So thank you very much. And over to you, Dr. Kaur, please.
Thank you, sir. Thank you so much. Ma'am, your mic, yeah, ma'am, you're on mute right now.
Are you able to hear me?
Yes, ma'am.
So you have done extremely well. You have tried to put up the things so beautifully. It's beauty of numbers. It has been represented beautifully. Now I just want to add a few things. Means the ways how we can.
Ma'am, your voice is cracking. Can you just repeat what you are saying?
Just a minute. Hello.
Yes, ma'am.
Can you hear? Is it okay?
Yes, ma'am.
Yes. I just want to add a few things. Actually, it's a very vast subject.
True.
And while teaching, I taught for about 16 years for class 11th and 12th, and small classes also. And Dr. Sharma has really said correct that normally math teacher is not welcomed
True.
in the class. They always
Very
feel
true.
it's there. And because I feel that hardly 25 to 30% of children are very much good in maths in average in class, and others are not good. So it happens so. But I thought that how can I make my class interesting? See, math class is not always the first one. Sometimes it's the fourth period, sometimes sixth period, sometimes eighth period. So it's like that. So in that case, a child coming from playfield, a child coming from music class, sometimes from library, sometimes from and they are coming to maths class. How can I bring them to environment of mathematics? Hai na? Even if I just start with a sum and then I put up an equation on the board and go on, so I don't think the children will like that. Hai na? So how can I bring? So what I used to do, I used to just ask dodging tables. 17 fours are, 4 eights are, and just like that, few only. So they will just come back from whatever they were, they just come back to the class. And sometimes I used to think of a puzzle in my mind. Take any 3-digit number, reverse it, subtract it. The number which you get is always divisible by 3. How? Well, that means a simple one. A simple one I used to carry definitely with that in the mind. Because the thing is, we say how to make maths interesting, but we have to find some ways.
Exactly.
And we have to find some ways how to make it. And what I used to do is, any chapter you pick up from any subject, suppose you take history or you take geography, and you see how much maths was there in the chapter. So if you come to history, there were dates, there were suns. So you come like that. Then we come to economics, come to any subject. And then that is what I used to say, that maths is related to all the subjects. And this type of, we have to give project works. So what I used to say, I used to give project work like this only. So you see what are the resembling points between these topics, these subjects. Any topic you take from your book only. And this is how they used to go deep in that. We have to create something. The thing is that if you directly go on equations and solving, so those who are good will enjoy, others won't enjoy. And we really want that a child should enjoy our subject and love our subject.
True.
To do something, etc. And then the thing is, what I feel is that math disciplines your mind also. And they say amusement is, Locke said that amusement is one of the field of mathematics. These puzzles finding and some sort of, see what I say, write all the digits, using all the 9 digits, you put number 1. Sometimes they put division, sometimes they multiply, sometimes means somehow playing with numbers. And when the child comes with playing with numbers, there was one thing very interesting, reversal I used to say. Reversal means 81. 81 is 9 into 9. And 81 reverse karo 18. And 18 is 9. 9 plus 9. 9 into 9, 81. 9 plus 9, 18. And it's a very small thing, but interesting. So every day, if you take something of that sort with you, a small thing with you, and I made it this thing, determined it that I have to take some, and this is how they just came. And one more thing, when they were on the higher side, what I used to do, we used to play tambola. We're all playing tambola. So tambola may, instead of just saying a number, I used to say cube of this number divided by that number, or any number, and a smallest of digits, or whatever, some equation, a small thing, and throw that and then take. So actually mental maths. So mentally it's important. So these are a few things I wanted to.
Even we keep mathematic tambola in our school. And every year students enjoy that, mathematical tambolas and certain mathematical race. Atul sir is here and he has normally conducted those races and students have enjoyed it.
Yes. So I think we get all these things, small things, so that and if a math teacher wants, she can definitely, she or he, whosoever, normally they make it a horror. And see, I simply used to think that I know in my mind that 50% of children won't enjoy. Because if you're taking class 10th, the child who has not learned maths from the beginning, you can't just imagine, you can't just expect that he will wonderfully do well. But if you have taken them from the small classes and then taught them like that, then it's okay. But all math teachers are not like that. It's not possible. All maths teachers are not, I mean, they won't put that much effort in it. And I used to tell them one thing more, that the pleasure of solving an equation, solving a difficult question, you get a very means divine sort of pleasure you get when you see the answer and your answer is correct. You have done so many things, and after that, oh, it was a difficult question, but you could solve it. And when you solve it and you see the answer, you get a divine pleasure. And that pleasure, I don't think you will get from anything else. Even though math gives that divine pleasure also. So this
True.
is how, so this is what, these are small things I used to use in my teaching and in the workshops also. So anyhow, you have done wonderfully well, and we can do. Thank you, Sharmaji.
Relan, thank you very much.
Thank you. Workshop was very nice. She has presented very well, and I have also added few things. So we can keep on.
So nice of you. Anyone who want to say anything? Any teacher? So finally, thank you very much, and we'll wind up with this. Thank you, ma'am.
Thank
Thank
you
you
so
for
much,
joining
sir.
and
Thank
giving
you.
your nice interaction, and nice details. Thank you very much. Thank you, Megha.
Thank you so much, sir. Thank you so
You were
much.
simply beautiful.
Thank you so much, sir.
Thank you very much.
Thank you. It's all your support and guidance. Thank you.
Thank you. Okay. Now we close meeting, and thank you very much. Okay.
Okay, sir.
Okay.
Okay, okay. Thank you so much, sir.